Hello everyone. Today we'll do atomic mass, molecular mass, and mole concept. So we'll start with the first topic of the first chapter. And as the syllabus is revised on 7th of July this year, in year 2020 by the CBSE. So the first topic for this year is atomic mass. So mass of an atom, एक atom का mass. So that is known as atomic mass. So we'll start with this. So actually, it is very difficult to have the mass of a single atom because the atom is extremely very small. So this was the biggest task for the scientists in the 19th century when the sophisticated techniques like spectroscopy was not invented at that time. So at that time, what the scientists did, they take hydrogen as a reference and हाइड्रोजन के साथ उन्होंने कंपेयर करके बाकी एटम्स का मास, हाइड्रोजन के एटम के साथ कंपेयर करके बाकी एटम्स का मास जो है वो डिसाइड किया. तो बेसिकली हाइड्रोजन क्यों सिलेक्ट हुआ? क्योंकि हाइड्रोजन इज द लाइटेस्ट एलिमेंट. तो इसको उन्होंने बाय डिफॉल्ट 1 जो है वो असाइन कर दिया मास. Or at that time, this one has no unit. This one had no units. It is without units. Okay. So ये relative हो गया, ये standard हो गया. अब जैसे kg होता है, 1 kg हो गया decide. तो अब इसके with respect to बाकी चीजों का weight कितना है? जैसे 1 kg जो weight है, उसके according मेरा weight कितना हो जाएगा? 80 या किसी और का कितना है? तो उसके multiples में weight आ जाएगा. तो ये लाइक टेस्ट है तो बाकी का इसके मल्टीपल में ही आएगा या फ्रैक्शंस में भी जा सकता है. रिलेटिव एटॉमिक मास ऑफ एन एलिमेंट इज मास ऑफ वन एटम ऑफ एन एलिमेंट ऑफ दैट एलिमेंट डिवाइडेड बाय मास ऑफ वन एटम ऑफ एलिमेंट. सो दैट विल बी द एटॉमिक मास. सो फॉर एग्जांपल अब ऑक्सीजन को अगर कंपेयर करेंगे हाइड्रोजन स्केल के ऊपर एटॉमिक मास के लिए तो ऑक्सीजन का 16 जो है वो मास आता है. So as I said earlier, कि इसके कोई units नहीं थे जब हाइड्रोजन एज अ स्टैंडर्ड था एटॉमिक मास के. तो 16 था, तो 16 टाइम्स हैवियर हो गया ऑक्सीजन हाइड्रोजन से. बट लेटर ऑन ये भी देखा गया कि हाइड्रोजन इज नॉट रिएक्टिव इन ऑल कंडीशंस विद मेजॉरिटी ऑफ द एलिमेंट्स, व्हेयरएज ऑक्सीजन इज मोर रिएक्टिव. सो इसको रिप्लेस कर दिया गया ऑक्सीजन के साथ. ऑक्सीजन को जो है वो स्टैंडर्ड ले लिया गया क्योंकि दिस इज मोर रिएक्टिव देन हाइड्रोजन. नाउ एज इट इज 16 टाइम्स हेवियर, तो अब ऑक्सीजन के साथ जो कंपेयर करके रिलेटिव एटॉमिक मास किसी भी एलिमेंट का आएगा वो उस एलिमेंट का एक एटम का मास डिवाइडेड बाय 1/16 ऑफ द वन एटम ऑफ ऑक्सीजन, बिकॉज ऑक्सीजन इज 16 टाइम्स हेवियर देन द हाइड्रोजन एटम. रिप्लेस हाइड्रोजन को इसलिए किया गया क्योंकि जो ऑक्सीजन है वो दैट इज मोर रिएक्टिव देन द हाइड्रोजन. वो ज्यादा एलिमेंट्स के साथ कंपाउंड बना रही थी नॉर्मल कंडीशंस के अंदर. जब ये डिसाइड हुआ कि ऑक्सीजन को स्टैंडर्ड मान लिया जाए, एट दैट टाइम ऑक्सीजन का कोई भी आइसोटोप नोन नहीं था सिवाय ऑक्सीजन 16 के. एट दैट टाइम ओनली ऑक्सीजन 16 वाज known, but later on oxygen 17 and 18 were also isolated. So this is difficult to take it as a standard now क्योंकि फिर वेरिएशन देते इसका अपना ही मास जो है वो वेरी करता है. Right now, as in present scenario, in the year 1961, carbon 12 जो है that is decided as the reference. So atomic mass जो है वो carbon 12 के based हो गया. So carbon 12 is selected because it is more stable, although it has isotopes, but the quantity of C12 is about 99%, more than 99%. I think C13 and C14 are known, but are in negligible amount in the picture. So now the system, as on date is selected in the year 1961. And according to it, the carbon C12 atom is assigned as mass exactly 12 atomic mass units. Now, the atom of carbon 12 is assigned as 12 atomic mass units. So, in the year 1961, the atomic mass unit is introduced. And what is this atomic mass unit? This atomic mass unit is exactly 1/12 of the mass of carbon 12, and its weight is equal to 1.66056 into 10 to the power minus 24 gram. Now, it is not the mass of hydrogen atom. So this is 1/12 of the carbon atom. 1/12 of the carbon atom is AMU. 1/12 of the carbon atom is atomic mass unit. So mass of a hydrogen atom in grams is 1.6736. Almost same, but is different. 10 raised to the power minus 24. So when we divide the mass of element hydrogen with AMU, that is 1/12 of the carbon atom, which is according to the 1961 upgradation, and the same standard is used till date. So relative atomic mass of any element, like here we take the example of hydrogen. Hydrogen mass of one hydrogen atom divided by mass of one AMU, which is equal to 1/12 mass of carbon. This is 1/12 mass of carbon atom. It is equal to 1.008 atomic mass unit. So as on date, atomic mass unit is also known as unified mass and is assigned by U also. Now, so this is the mass of one atom. Mass of one atom of hydrogen, right? Next is average atomic mass. So many of the elements exist in isotopes in the nature. Isotopes means these are the atoms of the same element, but with different mass number. They have different mass number, means they differ in their because atomic number is same, so protons are same, so they differ in their neutrons only. So average atomic mass is the relative mass of an element as compared to the mass of C12, taken as 12U as compared to one atom of C12. Again, same. This is how it is. But because the isotopes have different atomic masses, to how we can get a single value of this mass number. So for that, we'll multiply the atomic mass of each isotope of an element with its fraction available in the nature, and then we add the sum, and we sum all the results. So like here we take the example of chlorine 35 and chlorine 37. They exist in nature 75% and 25%. So 25% means 3:1, 25%, 25% means 3:1. So 35 chlorine is 3 and chlorine 37 is 1. So average atomic mass is mass of one isotope multiplied by its fraction in nature plus mass of the other and multiplied by its fraction divided by total parts. So 3 plus 1, 4 parts, so divided by total parts. So we'll get 35.5 U. This means the mass of one Cl atom, mass of one chlorine atom. It doesn't mean that chlorine exists with this mass. It means the sample of chlorine present in nature have average mass of its atom 35.5 U. Average mass of the atoms present in nature of chlorine. So no chlorine atom is with this mass. They are with the 35 or 37 U. But when we take the average of the sample of chlorine atom's mass, we get 35.5. And the method to calculate average atomic mass is multiply the mass of each isotope with its fraction, then sum up. Next is molecular mass. So molecules are made up of atoms. Since atoms are very small, so same the molecules are again very small. It is very difficult to get the mass of individual atoms. Then again they are measured by using the C12 atom, carbon 12 atom as a reference. So molecular mass of a molecule of the substance is the average relative mass of the molecule as compared to the carbon 12 taken as 12. Now how we can calculate? We will sum up all the atomic masses of the different atoms of all the elements present in a molecular formula of the compound. So here we have the example of calcium carbonate, atomic mass of calcium plus atomic mass of carbon, and this compound contains 3 times oxygen, so 3 into its atomic mass, so we get 100 U. 100 unified mass, 100 AMU means mass of one molecule of calcium carbonate. Next is gram atomic mass of gram atom. So what is this gram atomic mass? So in simple language, we can say that atomic mass has units U, unified mass, and atomic mass units. When this unit is replaced by gram, so it will become gram atomic mass. Now, what is this gram atomic mass? So gram atomic mass may be defined as the quantity of an element whose mass in grams is numerically equal to the relative atomic mass or the atomic mass. सिंपल है, जैसे कार्बन का जो एटॉमिक मास है दैट इज 12 U, so ग्राम एटॉमिक मास इज 12 ग्राम, हाइड्रोजन का 1.008 U and gram atomic mass is 1.008 gram. For nitrogen it is 14 U atomic mass and 14 gram is the gram atomic mass or gram atom, 1 gram atom. Now atomic mass of nitrogen is 14 U, gram atomic mass is 14 gram. So 14 gram of nitrogen is also known as 1 gram atom because gram atomic mass is equal to 1 gram atom. Similarly for oxygen it is 16 U and 1 gram atom is 16 gram. So when the atomic mass is taken in grams, so it is 1 gram atom or gram atomic mass. Now here one thing is important, the gram atomic mass should not be confused with the actual mass, should not be confused. So gram atomic mass is something different and actual mass is different. So gram atomic, for example, here is example with the hydrogen atom. So gram atomic mass, that is atomic mass in grams, for hydrogen is 1.8008 gram, but the mass of one atom is 1.672 into 10 to the 24 gram. So both are different. So don't confuse gram atomic mass, 1 gram atom. So 1 gram atom is different from the actual mass of the hydrogen atom or any elements atom. Now, gram molecular mass, same. Molecular mass is expressed in terms of grams. So calcium carbonate, we earlier to take example 100 U. So 100 U is the one molecule mass and 100 gram is 1 gram molecule, right? Then here are the some solved examples. ऐसे ही आपको पेपर में असेस किया जाएगा विद द हेल्प ऑफ न्यूमेरिकल्स, तो डायरेक्ट क्वेश्चंस कम होंगे इस टॉपिक में से. तो जैसे ये एग्जांपल है, कैलकुलेट मास ऑफ 2.5 ग्राम एटम्स, ग्राम एटम्स. So 1 gram atom means atomic mass in grams, atomic mass in grams. So 1 gram atom is atomic mass in grams. We change U to G. 1 gram atom. The 2.5 is multiplied by 2.5. So the answer is 60 gram. Now, how many gram molecules are present in 4.9 gram of sulfuric acid? Again, 1 gram molecules is equal to molecular mass in grams. So we can calculate 4.9 in by simply applying the unitary method. So here is the molecular mass 98 for H2SO4. So gram molecular mass, yeah, 1 gram atom. 1 gram atom is equal to gram molecular mass in grams. So gram molecular mass, so 98 grams. So 98 gram is 1 gram molecule. So we can easily find 4.9 gram is equal to 0.05 gram molecule. So you can solve these also. Next is mole concept. So what we did till now is atomic mass and gram atomic mass, molecular mass and gram molecular mass. For atomic mass, we have reference carbon 12 atom and unit is AMU. AMU is equal to 1/12 mass of the carbon atom and EMU is not equal to the mass of hydrogen atom. It is actually equal to the 1/12 mass of the carbon atom. Now, the gram atomic mass of carbon is 12 gram and mass of one atom of carbon has been calculated with this. So this is the mass of, has been calculated as 1.99 into 10 to the minus 23 gram mass of one carbon atom. Now, if the mass of carbon atom is divided by the gram atomic mass if divided by mass of one carbon atom, then we'll get the number of atoms in the 1 gram. Number of carbon atoms in the 12 gram. 1 gram atom. If, I repeat, mass of one carbon atom is 1.9924 into 10 to the minus 23. So this is experimentally determined. And 1 gram atom, gram atomic mass. This is 1 gram atom. 1 gram atom is equal to 12 gram. So if we divide this mass with mass of one atom, the quantity, this is quantity, 1 gram atom, atomic mass in grams. If we divide this with the mass of one atom, then we can find the number of atoms in this mass, which is 1 gram atom or gram atomic mass. Clear? Now, number of atoms in gram atomic mass, you have 1 gram atom. So, gram atomic mass of carbon, atomic mass in grams divided by mass of one carbon atom. So, we'll get this number, 6.022 into this. Similarly, if we apply same on the hydrogen. So 1 gram atom of hydrogen is 1.008 grams, and mass of one atom of hydrogen is 1.672 into 10 to the 24. So we divide 1.008 with this mass, we get a number which is again same we get in the case of carbon. So from these two examples, it is clear that the gram atomic mass, 1 gram atom of any element will always contain this number, 6.022 into 10 to the 23 number of atoms. So gram atomic mass, 1 gram atom of carbon contain this much. Similarly, in case of hydrogen, 1 gram atom, the gram atomic mass of hydrogen again contain this much atoms. So the gram molecular mass again for the substance also contains this much molecules. If we apply same on calcium carbonate earlier we have, so then again this is 6.022 into 10 to the 23 molecules. So this number 6.022 into 10 to the 23 is called Avogadro's number and denoted by capital N or N subscript capital A. The Avogadro number of particles of any substance are expressed in terms of mole. So this number is now named as mole. Is expressed as 1 mole. Mole means pile or mass of stones placed in the sea. 1 mole represents Avogadro number, and this number is 6.022 into 10 to the 23 particles. So 1 mole of carbon means this much particles of carbon. 1 mole of oxygen means this much particles of oxygen. So this 1 mole कहाँ से आया? जब हमने 1 gram atom of the substance को 1 gram atom of the element को हमने यानी कि ग्राम atomic mass को उसके 1 atom के mass से डिवाइड किया. Both are in grams. Mass of 1 atom in grams and जो 1 gram atom यानी ये gram atomic mass, both are in grams. So gram atomic mass for carbon 12 gram divided by its actual mass of 1 atom in grams. So we get this number, and for hydrogen same number, for oxygen same number, for nitrogen same number. So this number becomes a standard, which is Avogadro's number, and it is noted by 1 mole. Now why it is necessary? Because जैसे हम एक डस्ट पार्टिकल की बात करें तो एक सिंगल डस्ट पार्टिकल, a single dust particle contains 19 atoms, minus 19 atoms, 19 atoms in it. So it is very difficult to calculate small atom. So it can be expressed in a number which is mole. mole is the same as dozen. जैसे dozen जो है वो 12 को represent करता है, whether they are apples, oranges, pens, notebooks, copies, anything. And similarly, mole means this much of particles, and these particles may be ions, molecules, or electrons, protons, and now gram atomic mass in terms of mole. There is 1 gram atom of the element in terms of mole. Gram atomic mass in terms of mole. So and gram atomic mass is always equal to 1 mole. हमने पहले ही देख लिया जब divide किया. So 1 gram atom या gram atomic mass of this much atoms is expressed in grams. So gram atomic mass, 1 gram atom, this much atoms. They are always equal. So for sulfur, gram atomic mass is 32 grams. So 32 gram sulfur is 1 gram atom of sulfur, and this much atoms of sulfur are present. Now gram molecular mass is again same case. So gram molecular mass is equal to 1 gram molecule is equal to 1 mole molecules. Now in case of ionic compound, this mole concept is same, but in case of ionic compounds like sodium chloride, the NaCl is not giving a molecules formula, but rather it gives the ratio of number of cations and number of anions present in the sample. So formula of ionic compound does not represent molecule, but it's a formula unit. So it gives the ratio of the constituents taking that compound. So in case of ionic compound, the term gram molecular mass is replaced by gram formula mass. Otherwise, all the calculations are same. Like gram formula mass of Avogadro number formula units of formula units. This time, particles, molecules are replaced by formula units of an ionic compound expressed in grams. So gram formula mass of calcium chloride is 111 gram. So it means 111 grams contain Avogadro number of calcium and 2 times the Avogadro number of chloride ions in it. So 111 gram, 1 mole of calcium ions and 2 moles of chloride ions present in it. Now in terms of volume, so we have Avogadro's hypothesis: equal volume of all gases under similar conditions of temperature and pressure contain equal number of molecules. So what we get from here is the relation between mass and its volume, relation of mass of gas and its volume, and the established relation is at NTP. NTP means 0 degrees Celsius and 1 atmosphere. So 1 mole always occupies 22.4 liter. So 1 mole means gram atomic mass, 1 gram atom of any gas. So gram molecular volume or molar volume, this is 22.4. So gram molecular mass of gas is equal to gram molecular volume is equal to molar volume is equal to 22.4 at NTP. So NTP, normal temperature and pressure. So number of molecules in 1 ml of gas at NTP is known as Schmidt number, and its value is always 2.688 10 to the power 19. So this is the number of molecules in 1 ml of any gas. So that's why this relation is established. This one, the mass of gas and the volume, 22.4 liter. Now, what we cover is in mole concept. So 1 mole in terms of particles is equal to Avogadro number, right? Avogadro number of anything, maybe electrons, maybe protons, maybe atoms of any element. They are always considered as 1 mole. And 1 mole in terms of volume at NTP, that is 0 degrees Celsius and 1 atmosphere, is always equal to 22.4 liter for any gas. So this is in terms of volume and this is in terms of particles. Whereas in terms of mass, so for elements, 1 mole is 1 gram atom, gram atomic mass. For substance, it is gram molecular mass, 1 gram molecule. And for ionic substances, it is 1 gram formula mass of the substance. So for carbon, 12U is the mass of 1 atom, atomic mass, and 12 gram is the mass of 1 mole of atoms, right? So this is the established relation. This. Now, number of moles of substance is always given by given mass of the substance divided by molar mass. So this we did when we find the number of particles there in a gram atomic mass also. So given mass of the substance divided by molar mass always gives the number of moles of the substance, because molar mass is molecular mass in grams, mass of 1 mole of the substance, right? So that contains Avogadro number of particles, which is equal to 1 mole. So if 1 mole divided by any mass of the substance is always gives number of moles of that substance. So here are the few examples solved for you people. So I'm sending these to you, and we'll send also some unsolved questions. You can solve them, right? So bye for now. So